Just a quick word. We will ask the speakers, not now, but a bit later on, to come on stage for the big pictures with all the speakers, but a bit later on.
Yes, because we are at the last talk. It's an emotional moment, actually. I've been working for a year, and this is already the end. I mean, it's sad. Our next speaker is somebody who actually wanted to speak at, started speaking at the French Kit in the 2018 edition. In 2019, he talked again. He had so many talks that somebody called that the Pradeilles Kit. And even in the COVID edition of 2020, he had a talk about iOS memes. And of course, you know him. It's Vincent, and please welcome Vincent.
Good afternoon. I hope you still have a little bit of energy for this last talk of French Kit. So you see the title, Swift Quiz. I have 3 questions for you, and hopefully they should give you some nice ideas that you will be able to apply when you will be writing code again next Monday, hopefully. So let's get started with the first question, which is going to be about closure, capture list, and retain cycle. So let's see some code. So you can see a view controller. You can see this view controller has some properties. We have a service, a formatter, a label. So it's a simplified version of something that we are all familiar with, I think. We have a set of any cancellables because we are using combine here. And then inside view.load, you can see that we are making a call on the service and we are syncing on that call. And if we focus on the closure we pass to the method sync, you can see that inside of it, there are no optionals. The formatter and the label are both non-optional strong references. So we have some very nice ergonomics here. But of course, the big question is, will this code leak instances of the view controller? So we're going to do a vote, actually. So if we can have some light on the audience, so that I can see how it is split. Jean-Mi, la régie. So we're going to do it by show of hands. You can stand up if you feel very energized. So if you think that this will leak and will create a retain cycle, raise your hand. Okay, we have a few hands raised. Okay. If you think it won't create a retain cycle and won't leak, raise your hand. Okay, so there are more people for no, so that's good, because no is the correct answer, and let's try to understand why. So let's try to draw the memory graph of this code. So we have the view controller that owns both the formatter, the label, and the cancellables with strong references. Then the cancellables, through some other objects, owns the closure. And the closure retains only strong references of the formatter and the label, but not of the view controller. So indeed, there are no cycles here, and this code will not generate a retain cycle. But now, so indeed, capturing properties rather than self inside the closure won't create a retain cycle. But the big question is, why is weak self the go-to solution when this syntax seems to arguably be better? Like, could there be some trap? And indeed, there is a trap here. And it is that with this syntax, you capture a strong reference of the formatter and the label, but you capture the reference, the variables we're holding when the closure was created. So if they were to be updated later in time, the closure would still reference the older versions. So here it's not really a risk because these are let constants and so they cannot be updated. But if you're using a var, please note that this could introduce a bug. Please also note that if at a later time the let gets turned into a var, you won't be warned by the compiler that the closure has now become unsafe. So it can be a nice trick sometimes if like a weak self is becoming annoying, but double-edged sword, so use carefully, no refunds. Let's move on to the second question, which is about constant properties and mutating methods and value types. I forgot to write that one. So once again, let's introduce some code. So we have a struct called person. I'm storing an age in a let property. And then I have defined a mutating method called increment age. And I want to ask you, could we increment the property age inside that method? And what I like with this question is that if you don't know the answer, there are two, we could say, balancing powers that here if you try to infer it. On the one hand, you have a let property, which arguably should be immutable. But on the other hand, you have a mutating method. And maybe this mutating keyword could somehow make this work. So once again, let's put some light on the audience and let's do a vote. So raise your hand if you think it is possible to increment the age property with this method. Okay, I can see a few hands. So that was for yes, thank you. And for no, if you think it is not possible. Okay, so these times are a little bit more of a no, which is interesting because the good answer is actually yes. But it's not as straightforward as we might think because, of course, this code, the obvious code, doesn't work. So it's more like, is there a way so that at the end of the method, the property age will hold a value that has been incremented? Let me explain what I mean. And for that, I'm going to write some code outside of the method. For instance, I'm going to create a value of that type person. I need to store it somewhere. I'm going to store it in a variable. I'm going to make it a var because if I want to call a mutating method, I need it to be a var later on. So on this var, I could call my mutating method, but since it's a var, I can also do other things. For instance, I can assign a new value to it. I can assign a new value of that person. And when I assign that new value, for the argument age, I can read the current value and increment. So when we have a var, we can make it work. Now the question is, could we take this last line of code and make it work in the context of the mutating method? And as it turns out, we can. So first, from where do we read the current age? Pretty straightforward. We read it from self. And then where do we write the new value? Same answer, actually. We write it on self because it is possible to set a new value to self inside the mutating method of a value type. And this is a bit of a trick. So now, if we call the mutating method, at the end, it will indeed have somewhat indirectly, but still incremented the property age, at least from the point of view of the call site, from the caller, that is what will have happened. And so this technique is known as reassigning self. Let's give credit where it is due. I learned about it on obshi.io, a website I hugely recommend you check out if you've never checked it out. And keep in mind that it can result in some tricky code because it allows assigning, when you call a mutating method on a variable, it can potentially assign a new method to it without having an explicit assignment operator at the call site. So a nice bit of trivia, but for instance, if you're working with external SDKs for which you don't have the code source, keep in mind that they can do that from under you at any point. And now we move on to the third and final question, which is about empty enums. So let's once again have a look at a very weird piece of code. I'm defining an enum that is empty, so there are no cases in that enum. And then I define a function called magic, generic function, takes an argument of type empty, and returns a value of type t. And the empty implementation is here on purpose. It's not missing. It's not like abbreviated. This is the code. And I want to ask you, once again, by show of hands, do you think that this code builds? And once again, just like before, we have two competing powers here if we want to infer the answer. On the one hand, this seems to be wrong because there isn't even a return statement inside this method. But on the other hand, the argument is just so weird. So could it make it that there is something special here? So once again, by show of hands, if we can see the audience. So raise your hand if you think that this code does build. Okay, few hands are being raised. And raise your hand if you think it does not build. Okay, so slightly less, but we are still kind of split. The answer is that this code builds. And what's really interesting is why it builds, because there is math behind it. So for that, I'm going to show you a piece of code that will look absolutely different. It will look like it has nothing to do, but bear with me, it has everything to do. We find, once again, ourselves with our previous struct person, and I'm doing something weird with it. I'm taking an empty array, and I'm calling the method allSatisfy on it with the predicate that the age must be greater than 18. And if you run that code, you will see that this does not return nil, this does not return false, it returns true. And it's not a bug, it's not an approximation. This is actually mathematically sound. This is called a vacuous truth. And the logic here is that since the array is empty, it's impossible to find a counterexample that proves the property false. And since it cannot be proven false, then it must be true. And the compiler follows the same logic for our method, for our magic function. So let's write it down again. Since empty is a type that possesses no instances, it is impossible to create a valid call site for this method. Only thing you could do would be a force cast that would always crash. And so, since it's impossible to have a valid call site, all possible bodies are valid, and so we don't need to provide one. The compiler knows the body will never be executed, and it accepts an empty implementation as valid. And this seems very like a piece of trivia, but it's actually something that the Swift compiler relies a lot on, because this empty enum does exist in the Swift standard library. It's not called empty, it's called never, and you can do some pretty interesting things with it. For instance, if someday you need to conform to a protocol that expects either a result or a publisher, and you know that in your very special case, the publisher or the result cannot produce an error, you can use never for the generic argument error, and you will see that in that case, the compiler will not force you to implement the failure case. And it's not a bug. The compiler still checks for exhaustivity, but it knows that since the failure case can never be executed, it is an impossible cut path, and so the compiler won't expect you to write the code for it. Another very interesting place where the never type pops up is when you call fatal error. And it might seem a bit weird, because after all, fatal error is a function that is about stopping the execution of the program, but fatal error does have a return type, and guess what? That return type is never. And it lets the compiler know that every code that is after this method is dead code, and this is how you can have some nice warnings that you have dead code in your applications. So what should you take away from the never enum? Never is a very special type that lets us represent impossible code paths. The Swift compiler is smart enough to understand it and adapt the errors and warnings it will emit in consequence. And a cool consequence of that also is that when you are writing code and you're only focusing on making your code build, you can use never as a placeholder for code that you haven't yet written. And it's actually what you're doing, for instance, when you use fatal error or precondition failure inside a method. And one last thing, if you like math, you can Google for a pretty cool thing called the Curie-Howard correspondence, which is the rigorous mathematical framework behind what I've shown you here and the lock and key pattern also that Elliot mentioned this morning. Thank you. If you like this and you want more of the same, you can follow me on Twitter and on YouTube.
All right.
Thank you, Vincent.